So, in Algebra 2, one of the more difficult units is rational expressions and functions. The challenge of this unit is it combines factoring polynomials together with the ability to work with fractions. So if you're going to be successful at this, it would help to have a basic understanding of how to work with fractions. So that's what I'm going to look at right now. I'm going to look at multiplying, dividing, and then addition and subtraction of fractions. Of course, one of the other big things you need to understand about fractions is simplification, which will naturally come up as we work through this. So pay attention as we go through these examples. So first off, for multiplying and dividing, it's very important that you understand for multiplying and dividing, you do not need a common denominator. Please do not find a common denominator. If you do, you are literally just adding time onto the work that you are doing. There is absolutely no need for a common denominator, so please don't find one. If I want to multiply two fractions, understand what you're going to do is multiply straight across. So when I'm multiplying this, I will have 3 times 28. 3 times 28 is 84. 8 times 9 is 72. Then, in this fraction, what I want to look to do is simplify this, because I can see, looking at this, that, for instance, these are both even. So if I divide out a 2 to start, that will help me to simplify this. I'll have 42 over 36. I can see those are still even, and then I will get 21 over 18. And then at that point, I can see that these numbers are both divisible by 3. So I'm going to divide them by 3 to arrive at the simplified version of this product, which is 7/6. All right? All right. That's how I multiply two fractions. If I want to divide two fractions, the idea is I'm going to multiply by the reciprocal. Now, most people probably remember that you do something like that. You multiply by the reciprocal. You flip one of the two fractions that you were given. But the big thing you have to remember is which one. You multiply by the reciprocal of the divisor, the thing that is doing the dividing. So in this example right here, I have 42/15 divided by 105/24. This is the divisor. This is what I need the reciprocal of. If I take the reciprocal of the other fraction, then my answer is wrong. So I will get this. All right. Now, if I go ahead and multiply this, as some of you are accustomed to doing, 42 times 24 is 1008, and 15 times 105 is 1575. So you see those numbers, and you're immediately trying to think, well, how can I simplify this? Well, you might check. Clearly, they're not both even, so you might check and see if 3 goes into both of them. And it does. If I divide by 3, what I get is 336 over 525. Then at that point, I can still not see any obvious factors, so I might try 3 again, and I would find that if I divide by 3 one more time, I will get 112 divided by 175. And now again, I'm still not sure if this is fully simplified. I can check with 3. 3 does not divide either of these, or excuse me, yes, it doesn't divide either one. So instead, what I will look is 5 does not go in, and I can check division by 7. If I divide by 7, I will get 16 over 25. So this quotient right here is 16 over 25. And I got that by multiplying across and simplifying. Let's do one more of these. 25/33 divided by 30/44. All right. So again, I'm going to take the reciprocal of the divisor, and I will have 25/33 times 44 over 30. And I know I multiply straight across. And again, if you just go ahead and do this, 25 times 44 is 1100. And 33 times 30 is 990. Now when I'm looking to simplify this, you should notice these both end in 0. Ending in 0 means that 10 is a factor of both of these numbers. So I can divide out that 10 and symbolize that by crossing out these zeros. Then I'm left with 110 and 99. Well, 110 and 99 are both multiples of 11. I'm going to write this over here, even though at this point, honestly, you could probably just jump straight to the answer. This is 110 over 99, and then I'm dividing them by 11. If I divide them by 11, I get 10 ninths. So that is my answer. Now, a little note on this. For those of you who maybe aren't as comfortable with fractions, when you see people simplifying fractions, sometimes that can be a little bit mysterious. Well, I'm going to try and make it perfectly clear when I do this. You do not have to write this. Again, I'm just trying to make it perfectly clear. When I look at these two numbers and see that, hey, 11 is a factor of both, really what I'm doing is I'm saying that 110 is actually 11 times 10, and 99 is 11 times 9. And then I see this and I say I've got a common factor of 11 to both the numerator and the denominator. Since 11 divided by 11 is 1, I can divide those to 1 and just be left with 10/9. That is what you're doing every time you actually simplify a fraction, is you're looking to divide a number into two factors and divide out the common factors to 1. All right, so I did these three problems. Now, the other thing is, I should tell you, this is really not the most efficient way to do any of these problems. You see how much work I had to do here. And I don't mean in terms of I could have found a larger common factor to simplify these quicker, although certainly I could have done that. I am talking about something else. So, the term cross multiplication is a term that I do not like at all. But what's more, there's this other thing that some of you may have never been presented with or may not understand or know about called cross simplification. All right, cross simplification. Which is, if we understand how to multiply or divide two fractions, if we understand that the numerators are going to be multiplied together and the denominators are going to be multiplied together, well, that means I can consider any factor from the numerator and any factor from the denominator, and any like factors can be simplified, divided to 1. So watch how I write this. I'm not actually going to multiply 42 and 15. First off, I can write it as one fraction, although that step is really not even necessary. But this is what's going on here. This is how this problem will be computed. And then what I want to look for is, okay, how can I simplify these two things? Now, of course, I could have made my life easier if I had simplified these beforehand. 15 and 63 are both divisible by 3. 15 is 3 times 5. 63 is 3 times 21. So then I see the common factor of 3. I can get rid of those. All right? So let me rewrite this a little bit. I now have 42 times 5 over 55 times 21. As you get more used to this process, you'll be able to see where you can do this very quickly. 5 and 55 have a common factor of 5. 5 is, of course, 5 times 1. 55 is 5 times 11. So if I divide out these 5s to 1, I am now left with 42 over 11 times 21. Well, lastly, 42 and 21, those are both multiples of 7. And actually, you should be able to figure out that 42 is actually 2 times 21. So what I can do is divide out the common factors of 21 and be left with simply 2 11ths. Now this process seems a little bit strange the first time you're seeing it, but trust me, once you get used to it, it is much more efficient. If for no other reason, then I didn't have to figure out what 55 times 63 is, or 42 times 15. I just worked straight with numbers, smaller numbers that I know more about than whatever the product of 42 and 15 is. Let's take another look at this. Let's do an example with division. 35 24ths divided by 91 30ths. So in the previous example, I could have made this simpler beforehand by simplifying 15 over 63. Here, neither of these simplifies, I will tell you. But it's a division problem, so what I need to do is rewrite this as multiplication by the reciprocal of the divisor. And now what I want to look to do is look for common factors. So I see the 24 and the 30. I know those are both multiples of 6. So 30 is 6 times 5, 24 is 6 times 4. So again, I can get rid of those 6's and say that this is 35 over 4 times 5 over 91. All right. Now, I see the 35 and the 91. A little less obvious, but 91 is 7 times 13. 35 is, of course, 7 times 5. Now again, I want to stress this way that I'm showing simplifying this, you do not need to write this. I'm trying to make it clear the way fractions are actually simplified. 35 is 7 times 5, 91 is 7 times 13, so I can divide those common factors to 1, and I am left with now 5 fourths times 5 thirteenths, which is 25 50-seconds. Okay? Like I said, some of you may have never considered this before, but if you work with it enough, it does actually considerably cut down on the time you have to spend multiplying these out. All right, so I'm going to go ahead and move on. Adding and subtracting of fractions. Adding and subtracting requires a common denominator. The least common denominator, a phrase that you should be familiar with, is the least common multiple of the denominators. Okay? So, when you're doing this, you probably thought of, like for this first example, 4/15 and 1/6. Previously, what you might have done is something like writing out multiples of 6 and 15 until one coincides and using that. And that process will work for small numbers, but for larger numbers, not so well. And the big thing is we're going to get into this with algebraic expressions. And if you do that with algebraic expressions, it really kind of gets you nowhere. So what you need to understand is that what the least common denominator actually means is it is the simplest denominator such that each denominator divides the LCD. So the question is, how do I find this? Well, what you really need to do is factor the denominators and look at factors that are common and different. Apologize for my handwriting there. So, when I'm looking at 4/15 and 1/6, now of course, most of you could easily look at this and say 15 and 6 both divide 30. But we want a systematic approach to this for when I can't just pull the number out of thin air. Okay? So 15 is of course 3 times 5. 6 is 3 times 2. Alright? So, what do I want to do here? Well, I want a common denominator. The common denominator has to be divisible by both denominators. Well, then my LCD, clearly I need a factor of 3, because that is common to both denominators. The first denominator additionally has a factor of 5. The second one additionally has a factor of 2. 3 times 5 times 2 is 30. So my least common denominator is actually 30. So what I want to do here is think about, rather than saying, okay, how do I change this to 30? Think of this more in terms of, if my least common denominator is 30, 3 times 5 times 2, what factor is needed to change each of these to that common denominator? So for 3 times 5, I additionally need a 2. For 3 times 2, I additionally need a 5. To convert, 4/15 times 2 over 2. I'm multiplying by 1, which will give me an equivalent value. 1/6, I'm going to multiply by 5 over 5. So what does this give me? Well, this gives me 8/30 plus 5/30. 8/30 plus 5/30 is 13/30. At this point, I would, of course, look to simplify this fraction if I could, but clearly 13 is prime, so it doesn't share any factors with 30. All right, let's do some more examples of this. 4 minus 12/5. This is a much easier example because there's only one denominator to be common with. 4, I understand, has a denominator of 1. Some of you are used to writing this. Truth be told, you really don't have any need of writing it, but it is 1. So my least common denominator must just be 5. So when I want to convert this, 4 over 1 needs to be multiplied by 5 over 5 because this denominator needs a factor of 5. The second fraction is fine. So what I have then is 20/5 minus 12/5. 20/5 minus 12/5 is 8/5. And again, that will not simplify. So that's done. Now I'm going to keep doing a few more examples because, again, you have to get the hang of this, and if you are not good with it, it takes seeing it a few times. Here I have 1/7 minus 11/28. So again, if I want to think about a common denominator, I know that 7 is prime, and I know that 28 is 7 times 4. So how do I find a common denominator? Well, my least common denominator needs to be divisible by 7 and additionally by 4. So my least common denominator is 28. So 1/7 needs 4. So what I will do is say 1/7 times 4 over 4 minus 11/28, which is fine. And what is this? This is 4/7, 4/28, it's my mistake, minus 11/28, which is negative 7/28. And this does simplify. This is negative 1/4. Okay? 2 more examples. 11/12 plus 9/10. Okay, so again, I want to think about this. I know that 12 is 2 times 6, and again, I could factor that more. I know that 10 is 2 times 5. Well, I could factor 6 more, but at this point in this factorization, I can see that they both have a 2 in common. This one has a 6, where this one has a 5. So my least common denominator needs to have that 2 that they have in common, and a 6, and a 5. Okay? Yeah. So 11/12. 12ths are missing 5. So I need to multiply in a 5. 9/10. Tenths are missing the 6. So I need to multiply in a 6. My least common denominator is going to be 60. So what do I have here? I have 55/60ths plus 54/60ths. If I add those together, what do I get? I get 109/60ths. And again, you would look to simplify this, but since you know that 60 is divisible only by the primes 2, 3, and 5, you can check and none of those goes into 109. So that is my simplified answer. Alright, let's do one more example. Here I have 3 fractions. 3 fractions doesn't necessarily make this more complicated, again, if you're considering the method that we have been talking about. If I look at 20, 35, and 14, well, again, you want to think about factoring these down. 20 is 4 times 5, which makes it 2 times 2 times 5. 35 is 5 times 7. And 14 is 2 times 7. So when I'm figuring out my least common denominator, I know I need 2 as a factor, but not only that, since every denominator has to be a factor of the least common denominator, 1, 2 is not sufficient. 20 is divisible by 4, it's divisible by 2 squared. So I need 2 2's in my denominator. I've got a 5 as a factor, and I've got a 7 as a factor. So I additionally need those. My least common denominator then is going to be 4 times 5, which is 20, times 7, which is 140. Alright, so if my least common denominator is 140, then what do each of these need? Here, I need a 7. Here, I need 2 2's, I need 4. Here, I need both a 2 and a 5, so I need to multiply in a 10. So let's go ahead and show this work. I've kind of run into my workspace here, so this is going to be a little bit sloppy, but 3/20 times 7 over 7, 6/35 times 4 over 4, minus 9/14 times 10 over 10. So that way I can see that 20 times 7, 35 times 4, 14 times 10, all of those are 140. So what I can do now, I'm just going to go ahead and write these as a single fraction because that's the whole idea. I now have a common denominator. 3 times 7 is 21, 6 times 4 is 24, minus 9 times 10 is 90. So what does that give me? 21 plus 24 is 45. 45 minus 90 is negative 45. Negative 45 over 140. Both of these are divisible by 5. And what I get is negative 9. If I take out a 5, I will have 4 times 7, which is 28.